Okay, so we're going to go through the geometric sequence notes for this video, and I am going to just start with the note sheet that's on your Canvas class. Okay, we talked a little bit about geometric when we were talking about that very first example in the arithmetic sequences. So this is just going to formalize some of the notes. Geometric sequence, a sequence in which a common ratio, right? Common ratio. I think a couple of you might have seen that on your practice assignment. Common ratio is for a geometric sequence, and it is multiplied to each term. So just like when we talked about the arithmetic sequences always having a value that's added to each term, with a geometric sequence, there is some common ratio that is multiplied by each term. Okay? So if we take a look at the first example here, we have a sequence 2, 8, 32, 128. It's a lovely little sequence there. You're asked for your first term, right? U sub 1, so that's 2. U sub 2 is the second term in the sequence. And the common ratio, well, how do you get from one term to the next? To get from 2 to 8, you need to multiply times 4. To get from 8 to 32, you multiply times 4. So the common ratio here would be 4. Okay. Number 2, use the sequence to answer the following. The sequence we have here is 28, 7, 7 over 4, and then 7 over 16. U sub 2, our second term is 7. U sub 4, which is the fourth term, is 7 over 16. And the common ratio, now any of you sitting out there thinking, well, you divided by 4. That's great. You did divide by 4. But because the common ratio has to be a multiplier, the way we show division by 4 is to actually write the fraction 1/4, and that's what we're multiplying by each time. So if you take 28 times by 1/4, you get 7. If you take 7 times 1/4, you get 7 over 4. Keeps going throughout the rest of the sequence. All right. Let's see. We'll change a color. Number 3, we need the first 4 terms. So U sub 1 is 3. So you're going to start with 3, and you have a common ratio of 4. So that means we're going to take this term. To get the next term, we want to multiply times 4. So 3 times 4 is 12. To get the next term, I'm going to keep multiplying times 4. 12 times 4 is 48. And I need to do one more multiplication times 4. And 48 times 4 is 192. All right. Now, in true set builder notation, we talked a little about this. You would actually have the braces around it. Because I had put the blank spots in there for you, there's no concern that you don't have the braces. All right, number 4. So number 4 states below the first 5 terms, 1, 2, 3, 4, 5. Okay, I gave you 5 blank spots, in which U sub 3 is 10. All right, so I'm going to go ahead and mark 10. This is V1, 2. This is my third position. Has a common ratio. Should be ratio. Let's fix a little typo there. Sorry about that. A common ratio of 1/2. So to work down the sequence, right, to continue the sequence moving forward, we're going to take 10, and we're going to multiply times 1/2. So that would be 5. And then I'm going to take 5 times 1/2, which would be either 2.5, or I have a habit of just writing things as fractions, so 5 over 2. To go the other direction, right, I need to think about what number times by 1/2 is 10. Well, that number would be 20. And then to get the first term here, I need to think of what number times 1/2 is 20, and that would be 40. Half of 40 is 20. Half of 20 is 10. Half of 10 is 5. Half of 5 is 5 over 2, or 2.5. Either one is appropriate. All right, so that's a little bit of practice with those geometric sequences, kind of getting used to the common ratios. All right, so we have another handy-dandy formula here. I think I said this with the arithmetics. You won't need to memorize this specific formula. You will need to know when to use it. So this is a formula to find a specific term. The R is going to give you a hint that this deals with common ratios, so it is a geometric. All right, and your n value has to be greater than or equal to 1. It's kind of goofy, but you can't have a sequence with no terms in it. So if n was less than 1, you would end up with negative term numbers, which is just a weird concept. So for this particular formula, it's n is greater than or equal to 1, so you actually have a sequence. All right, problem number 5, find the common ratio. So I want to find my R value. I know my U sub 1, and I know U sub 5. So let's fill in some information. All right, U sub n, which is going to be my last term, so it's 162, is equal to my first term times the common ratio raised to the n minus 1. Well, in this case, it would be the 5 minus 1 power. All right, so if you're going from term 1 to term 5, that's 5 terms. So a little bit of solving here. I'm going to divide both sides by 2. That gets me 81 here. 5 minus 1 is 4. Whoa, that's a horrible 4. And I made it even worse the second time around. So we have 81 equals r to the 4th, and we need to figure out what r is. So you probably have done this, I'm hoping, maybe Math 3. But as a reminder, how do you get rid of exponents? In this case, we have a 4th power. So I need to use a 4th root. All right. So if I take the 4th root of 81, I'm going to get 3. So my common ratio is 3. Okay. So that ends problem number 5 here. Problem number 6, same type of question. Find the common ratio for a geometric sequence. Let's see what we've got here. We know our first term. We know our 4th term. Okay, so 4th term here is going to be 25 over 16 is equal to the first term times my common ratio. I don't know what that is. I got to figure it out. Raised to the n minus 1. In this case, n is 4. All right, so I need to take this 100, and I want to divide 25 over 16 by 100. So let's see what happens there. So 25 over 16, and I want to divide by, let me make sure I have everything in parentheses that I need in parentheses. So divided by 100, that is one wacky little decimal there. So it looks like 1 over 64. All right, so 1 over 64 is going to equal r to the 3rd. To get rid of a power of 3, I need a cube root. Okay, powers and roots undo each other. So the cube root of 1 over 64 is going to be it's going to just turn into r is equal to 1 over 4. And that ends problem number 6. All right, last problem, because I'm pretty sure, let me take a quick look at the last page. Yeah, that last page is just blank. I don't know why it pops up, but it does sometimes. All right, so let's see what we've got here. Find the number of terms. So I want to know n in this problem. When I know my first term, I know my last term, and I know my ratio, my common ratio is 4. So let's see. I'm going to say my last term is 768, which is equal to my first term, times the common ratio raised to the n minus 1 power. Common mistake here. Common mistake. Whoops, I'm writing extra stuff here. Please do not take 3 times 4. You can't do it. Okay? Mathematically, the powers that be said we have to follow order of operations. And if you remember your order of operations, you have to do any exponents before you can do any kind of multiplication. So this 4 is attached to that n minus 1, and it's going to stay attached to that n minus 1. But what I can do is I can divide both sides by 3. So 768 divided by 3 is 256. And this is equal to 4 to the n minus 1. Yeah, that's kind of a special treasure. But what we've got here is a situation where if you can make the bases of the two sides of the equation be the same, then what has to be true is that the exponents are the same. So what do I mean by that? What I'm looking for is, can I rewrite 256 as 4 to some power? And I'm pretty sure, I want to do a quick double check, but I'm pretty sure 4 to the 4th is in fact 256. So you can do a quick guess and check on that. And what ends up happening then is you've got 4 to the 4th equals 4 to the n minus 1. These 4s, because they are the same, basically mean you can rewrite this as 4 is equal to n minus 1, and then n is equal to 5. So how many terms? 5 terms. Okay. All right. So this is the note sheet for the geometric sequences. What I'm going to do is have you guys pop into the Zoom meeting if you have any questions. And other than that, I hope this helps you get some practice problems done. Let me know if you have any questions.